All right, well, go ahead and get started. Hi, good afternoon, everyone. My name is Meta Polywall with the Orange County Water District, and I'm excited to welcome you to our webinar today. Today, we will focus on our collaborative efforts to address groundwater contamination caused by industrial chemicals and detected in the southern portion of the Orange County Groundwater Basin. While not the responsible party, OCWD is working on ways with its partners to clean up the pollution in a collaborative effort with state and federal regulatory agencies. Right, so before we get started, I want to mention that we are in webinar mode, so attendees will be muted to reduce any background noise. The webinar is being recorded and will be published on OCWD's YouTube channel. Lastly, we'll take questions at the end of our presentation, so we encourage you to submit your questions in the Q&A box located at the bottom of your screen. We will do our best to get to as many questions as we can today and address questions most relevant to the information presented today by our speakers. In the event that we're not able to get to your question during the webinar, we are able to follow up with you after, so please do include your email address with your question as well. And if you think of something after the webinar and want to get in touch with us, please feel free to email us at info@ocwd.com for any follow-up questions. Without further ado, I'd like to introduce our speakers for today. Bill Lever is a principal hydrogeologist for the Orange County Water District and has more than 30 years of professional hydrogeologic experience skilled in a wide range of disciplines, including contaminant hydrogeology, soil and groundwater assessment and remediation, groundwater well siting, design, construction and testing, safe field analysis, groundwater resources management and development, groundwater basin hydrogeologic analysis, recycled water groundwater recharge planning, design, permitting, and implementation, artificial recharge, and groundwater adjudication litigation support. Bill joined OCWD in 2020 and manages the South Basin Groundwater Protection Project and the Sunset Gap Seawater Intrusion Barrier Project. Angela Turner is an engineering geologist and project manager in the Site Mitigation and Restoration Program at the Department of Toxic Substances Control. She has 23 years of experience in the private and public sector, performing site assessment and remediation at sites including fuel and chemical distribution, manufacturing, metal shredding and recycling, plating, utilities, and schools. She joined DTSC in 2018 and manages sites under Chapter 6.5 and 6.8 out of the Cypress office. Dr. Mona Beruz is the chief of the Site Cleanup Program at the Santa Ana Water Board. As the chief of the Site Cleanup Program, she provides comprehensive oversight of the environmental investigation and remediation activities across a wide range of contaminated sites within the Santa Ana region, from large industrial facilities to smaller operations like dry cleaners and plating facilities. These sites are typically impacted by hazardous chemical discharges, including volatile organic compounds, petroleum hydrocarbons, 1,4-dioxane, PFAS, percolate, and chromium-6 into the soil and groundwater. So thank you so much to our speakers for joining us and our audience for joining us today. I will kick it off to Bill, who'll get us started.
Great, thank you, Meta. Can you all see my screen?
Yes.
Great. All right, well, thank you all for joining us today. And thank you to DTSC and Regional Board for volunteering to co-present with us today on the South Basin groundwater contamination issues. So a little bit about Orange County Water District. We were formed in 1933 through a state Special Districts Act. The district currently provides about 85% of the drinking water supply within our service area, which is the north and central portion of Orange County. We serve exactly 19 cities and retail water districts within our service area that provide water to about 2.5 million people. Our district is managed by a 10-member board representing all of the cities within our service area, and the district also manages our rights to the Santa Ana River water. So if I can get you to focus in on this inset map before we stare at the cross section. The blue area here represents roughly the outline of the Orange County Water District service area. And some of the highlights of this area are our recharge facilities in our 4-bay area, the area north roughly of the I-5 freeway shown here at right along B. And then I also wanted to point out the Santa Ana River, which is our main water facility here, which provides our water for recharge and off-river recharge here in the San Diego basins. And then the South Basin area is located here along the 55 freeway, north of the 405 freeway and south of the 5 freeway. So now jumping over to our aquifer system. The district's divided the aquifer roughly into 3 units: a shallow aquifer, a principal aquifer, and a deep aquifer. North of the 5 freeway, which is approximately where B is here, is what we call our 4-bay area. It's the unconfined portion of this aquifer where surface recharge is able to move vertically down into all 3 of the aquifer units. And then seaward of the 5 freeway, or B here, the shallow unit becomes separated from the principal aquifer. So the principal and underlying deeper aquifer become confined, where surface recharge no longer occurs. Recharge occurs horizontally through the aquifer layers. Also wanted to point out here along this cross-section location is the South Basin area occurs in the pressure area, the confined area, roughly shown by this bar right here. Okay, focusing in a little more on the South Basin area. As Meta mentioned, the South Basin area has a long history of industrial manufacturing, microchip manufacturing, waste product recycling, and through all of these activities from the late 1950s until present, some of the sites still are operating. Industrial releases have occurred. So this cross-section represents various chemicals being released into the shallow aquifer system, moving along with the flow of groundwater to roughly the south. We have monitoring wells that monitor this water, and we're also indicating here potential pathways for contaminants to move into the principal aquifer system through improperly abandoned irrigation and water supply wells that have existed in this portion of the basin for well over 100 years. All right, so what are the contaminants in the South Basin? Primarily VOCs and perchlorate releases have occurred. The map to the right shows an amalgamation of the highest concentrations detected throughout our remedial investigations of the contaminants shown here, which are PCE, TCE, 1,1-DCE perchlorate, and 1,4-dioxane. The color graded map here shows the highest concentrations in dark red, over 10,000 parts per billion, down to the lowest concentrations, down to 1 part per billion, shown in the blue outline. The dark hatched areas are the release sites where most of the chemical releases have occurred. These releases have, over decades, formed long commingled plumes that move southward in the direction of groundwater flow. Also shown on this map are large-scale municipal supply wells, shown here in red. And I wanted to point out here IRWD3, which is the well that initiated our investigation into the South Basin. IRWD3, back in 1998, started getting concentrations of VOCs showing in some of our test water samples. And IRWD3 is only perforated in the principal and deeper aquifer. So at that point, we knew there was an issue, and we began investigative work. Also shown here are SAM wells, SAM, which simply stand for Santa Ana Monitoring Wells. These are wells the district installed as part of our remedial investigation efforts to determine the vertical and lateral distribution of this contaminant plume. So the district is conducting this work under the authorities provided to us under the OCWD Act. And although it's not a Superfund site, we're conducting the work in accordance with the National Contingency Plan and in coordination with the Regional Board and the DTSC. So a quick chronology of the activities in the South Basin. So as I mentioned before, in 1998, VOCs were detected in IRWD well 3. In 2006, OCWD began active investigations in identifying the source sites, conducting field investigations. In 2015, we issued a preliminary remedial investigation report. In that report, a number of data gaps were identified. Further investigation occurred through 2018. And then the district, through its consultant, compiled all of the data gathered to date, issued a supplemental remedial investigation report in 2020, and then began our feasibility study of potential remedial alternatives. That was finalized in January of 2023. And since that time, the district has initiated the preparation of our interim remedial action plan, or in NCP parlance, our proposed plan to remedy the groundwater contamination in OU2, and I'll touch on that in a minute. And then we also concurrently initiated our CEQA analysis of the proposed plan. And then in 2025 on, we'll begin our preliminary design investigations, remedy design, and then construction. So just to touch quickly on the district's efforts in recovering costs for our remedial investigations and work that will be ongoing over the next several decades. We filed suit against over 20 responsible parties in 2008. We've settled with 17 of those parties, and we still have ongoing litigation with 5 other parties. So what is a feasibility study? So a feasibility study establishes our remedial action objectives. What is it we plan to achieve by implementing a remedy? We evaluate various remedial technologies. We refine that list into a smaller list of remedial alternatives, and then we evaluate all of those alternatives against the criteria established in the National Contingency Plan. So the alternatives that we developed were a no action alternative, which is a requirement of NCP, and it simply is a baseline upon which the cost and effectiveness of the other alternatives are evaluated. We evaluated monitored natural attenuation, groundwater extraction and treatment with disposal to the sewer and GWRS, groundwater extraction and treatment with re-injection of that water back into the shallow aquifer system. We evaluated in situ chemical oxidation. And then alternative 6 was a combination of groundwater extraction and treatment along with in situ chemical oxidation. All right, so touching base on alternatives 3 and 4. Alternatives 3 and 4 are both groundwater extraction and treatment alternatives. The alignments of our groundwater extraction wells are shown here by these black dots. The black dots don't represent the number of wells, they're simply a symbology to show where the alignments occur, and there are 8 alignments. The difference between 3 and 4 is alternative 3 will treat the water locally to remove VOCs and other contaminants that can be removed through GAC. That water will then be discharged to the sewer, where it will flow to GWRS and be treated at GWRS, and then ultimately be recharged back into the basin up in those recharge basins up in Anaheim. Alternative 4 is a similar process in extracting groundwater, but then that groundwater is treated through GAC and reverse osmosis and is re-injected back into the shallow aquifer system nearby each site. To touch base on the water we are treating, our efforts are focused on what we're calling operable unit 2. Operable unit 2 is the groundwater that is off-site of the source site. So each of the source sites has or is planning to conduct remedial investigations and implement remedies. And Mona and Angela will be talking about those. So focusing in a little more on the northern part of the basin where we're implementing or we're reviewing alternatives 3 and 4. You can see here that the responsible sites or the release sites are shown here by the hatch patterns, and they have the names of all those sites. Some of the sites have planned groundwater extraction systems shown here in blue dashed lines. Some sites have existing groundwater extraction systems shown here by these blue capture lines. And then other sites have existing in situ or planned in situ remedies in place. And so you can see our alignments are focusing in on the high concentrations of the plume and with the goal of preventing the plume to move any further laterally or down gradient to the south. And then here in the southern portion of the plume, alternatives 3 and 4, you'll see 2 alignments. And these 2 alignments simply act as catcher's mitts or backstops to, again, prevent the plume from moving any further south of where it currently exists. So alternative 5, in situ chemical oxidation, you'll notice that the alignments are very similar to our alternatives 3 and 4. These alignments don't represent extraction wells, they represent injection well alignments where sodium persulfate would be injected and the contaminants would go through an oxidation process that would break them down into inert contaminants. And then alternative 6 has almost all of the same groundwater extraction alignments, except for this alignment here in the center of the plume was removed and replaced with an in situ chemical oxidation alignment, again, using the sodium persulfate as an oxidant. So touching base real quickly on the NCP criteria used to evaluate each of these alternatives. The first 2 criteria are called threshold criteria. These criteria are kind of a pass-fail. They either meet the threshold criteria or they don't. If they do not meet the threshold criteria, they're no longer considered a viable alternative for a remedy. The next 5 alternatives are called balancing criteria, and they are used then to rank each criteria against each other as far as their effectiveness. And then this last criteria, state and community acceptance, these are actually 2 separate criteria, are evaluated after the remedy's been selected from the proposed plan. So a quick comparison, red meaning they ranked low, dark green meaning they ranked high. So 5's best, 0's lowest. 0 means they weren't even ranked because they didn't meet various criteria. So you can see alternative 3, the highest score would be the highest ranked alternative. Alternative 3 ranked highest among all of the alternatives we evaluated, closely ranked against alternative 4. And alternative 4 simply cost more and was slightly more difficult to implement because of the additional treatment processes needed. In an alternatives cost comparison of the active alternatives, the ones that met the remedial action objectives, alternative 3 was the least cost alternative by a long shot. The next least cost alternative was alternative 4, which was almost double the cost of alternative 3. And these costs include the capital, the O&M, and the maintenance and monitoring costs over a 30-year project duration. So as I mentioned before, our current activities are the preparation of our proposed plan, which would identify the preferred alternative. We're also completing our CEQA analysis by preparing a draft programmatic EIR. Those will be circulated for public review concurrently in the fall of 2024. Once we have received and addressed all of the public comments after the 45-day public review period, we will address those comments and then present the comments and responses to our board as the lead agency for consideration of approval of the draft programmatic EIR and the draft proposed plan. At that point, if the board decides to move forward with this project and approves both the proposed plan and the PEIR, we would initiate our preliminary design investigation, which would then also require probably additional environmental analysis, which would be amended to the PEIR, and then we could move into design and construction phases. And with that, I am going to pass it to Angela Turner for her to present on some of the DTSC's activities in the South Basin. And thank you.
Thanks very much, Bill. I will, oh gosh, I'm not pointed very well there. Okay, thank you for coming and spending a bit of your afternoon with us. Let me get my screen shared. I wanted to share with you a cleanup plan that we have at one of the sites that, okay, I think that is sharing. Can you see my slides?
Yep.
Okay, great. Wanted to share a cleanup plan at one of the sites that Bill showed on his map, MB Plating. We currently have out for public comment an interim measure work plan for in situ thermal remediation. The public comment period started on May 3rd and it'll go until June 3rd. And that cleanup plan is available in its entirety on our EnviroStore website. So this is where the site is located. MB Plating is right here. This is a kind of zoom in on the map that Bill shared. The area is north of Warner and west of Grand. Here's the 55 freeway down here. DTSC manages several of these sites. I personally am the project manager for MB as well as Delayed, former Dyson Electronics, and Textron, also known as Cherry Aerospace. So MB Processing is a metals finishing facility, and they mostly work on aerospace projects. They operate 11 buildings here at the site, but most of the releases come from, find my little pointer here, the center of the site. This building and this building are the primary, with minor impacts from this one and this one. So here in the corner core of their property. And they're surrounded on all sides by other industrial neighbors. They're permitted and inspected by Orange County Healthcare Agency under permit by rule. Their past uses of PCE and TCE were related to cleaning of the metal pieces before they were coated, either plated or painted. So they have constituents of concern that include PCE, TCE, 1,4-dioxane, hexavalent chromium, and PFAS. The primary risk drivers are the PCE and TCE. So we've been in a corrective action consent agreement with the facility since 2001. And in the intervening years, we've done plenty of investigation as well as installed a couple of existing interim measures. There is a floor ceiling in this building over here to mitigate vapor intrusion. And there's also a system of carbon filtration for indoor air and indoor air sampling to verify protectiveness. And then this in situ biodegradation of groundwater is the interim measure that the existing in situ measure that Bill referenced on his slide. It's a injection of emulsified vegetable oil along with nutrients and microbes. And the proposed interim measure is the electrical resistive heating that's out for public comment currently. So this is a zoomed in view of the buildings in the center of the site. And this is the area where that floor seal is located, right over one of the highest areas of impact here. There's another one down here. These green rectangle shapes are former vapor degreasers, and the dark colored isopleths are 100,000 micrograms per kilogram of total VOCs in soil. The groundwater contours look very similar to these shapes. And all of this work is going on in the shallow aquifer that Bill showed on the cross section at the beginning of his presentation. Nothing goes down into the principal one. So a bit about how in situ thermal remediation works. There will be power that gets brought in from the regular utility that's going to need to get upgraded by SoCal Edison because this equipment is really power hungry. That'll go to the equipment enclosure and then run out to the wells where these electrodes are installed into the soil in casings that also contain a vapor recovery component. So they will introduce electricity into the subsurface. And because the soil and water are such poor conductors of electricity, they will heat up. So this red area represents the treatment zone that will experience those elevated temperatures. So the groundwater will get heated to a level above the boiling point of the VOCs, and they will partition out of solution as steam and get recovered as this green cloudy representation, recovered by the vapor recovery system. And so that will go in these green lines over to a treatment center system. So it'll get cooled and the condensate will go through GAC to the sewer. And then the dried air will go through carbon as well to the atmosphere. And those activities will get permitted by OC Sanitation and South Coast Air Quality Management District, respectively. So this is the plan for how these components are going to be laid out at the MB site. So the orange circles are where electrodes will be installed vertically, and the lines represent an overhead view of forings that'll be installed at an angle, because a lot of the mass exists under these buildings that have very large bolted down, integrated with the building process lines. And this is still an operating facility. So getting in there with all of this equipment just wasn't possible. The blue circles are locations where workers will be able to go in and install probes with hand auger equipment. The green are temperature and pressure measurement locations. There will be 67 electrode wells spaced about 14 to 16 feet apart. So they're installed, these ones will be installed in a row. So the drill rig will line up with the front bumper pointed to the south, the mast to the north, and it'll be angled from 6 degrees to 64 degrees off of vertical to install these wells. And then there's going to be a treatment compound over here in the bottom left. So this is how the electrodes and the monitoring points are built. I think this might be a bit hard to see, so I'm just going to zoom in. Yeah, here we go. I'll start from the bottom up. So there is a lower electrode that's installed in conductive backfill that's carbon-based. And the total depth is between 45 and 60 feet for these. So that will treat the deeper zone. And then there's a sand isolator. Here's the water table at 20 feet, then a shallower electrode. So the vadose zone as well as the saturated zone will get treated. And then up here is the vapor recovery screen. There's also a drip tube to introduce fresh water into the well there, because as the vapor gets extracted, that can be drying, and the electricity will spread out better if the soil retains its moisture. So the water will get needed there on an as needed basis. So over here, we have a temperature and pressure location. So this is a casing that will just have temperature and pressure sensors. And then this is, let me zoom out a little bit so you can see that, a soil vapor monitoring location where we'll be able to sample to both monitor for the success of the cleanup as well as protectiveness of the occupants, because folks will still be in the buildings above. And we want to make sure that the existing vapor intrusion risk that we've assessed doesn't become elevated as a result of our activities. So this is a, let's see, how do I make this video go? Maybe if I turn off the pointer and go back to the cursor. I didn't practice this one in presenter mode, I'm sorry. Oh, there we go. So this is a 3D mock-up of the plume mass, and then the blue lines are the thermal treatment wells that will intersect it. And so the idea was to, based on various depths and angles, get coverage of the entire area that needs to get treated and get the heat distributed through those areas, even underneath the building. Maybe I'll let that go through one more time just because it's kind of cool. Okay, enough of that. So we'll do a lot of sampling before, during, and after the project to guide operational decisions and evaluate how effective the cleanup has been, and as I mentioned, to ensure protectiveness of human health. So we'll be sampling indoor air quarterly to make sure that it's within commercial screening levels. We also have a perimeter of soil vapor wells to sample every month to monitor for any kind of lateral spread to buildings that are not currently at VI risk, to make sure they stay that way. Subsurface temperatures will be measured daily. Pressures will be measured weekly. We're going to want to really keep close tabs on the pressures there and make sure that they are negative below the pressure of the air inside the building, so that we have transport headed from the occupant spaces into the subsurface as opposed to the other way around, so we don't induce any more vapor intrusion risk. The waste treatment streams will include the air treatment system and the water treatment system. Those are both sampled according to the permit conditions from SCAQMD and OC Sanitation. The inlet concentrations will be measured really closely because that will give us the tools when compared with flow rates to evaluate the total mass that we've recovered. So the designers of the system have calculated, based on how much mass is in the ground, how much energy needs to get added to deal with that mass. And so once about 60 to 70% of that energy has been provided and the temperatures are at or near hydrostatic boiling, we'll start looking for decreasing PID readings to show that we're getting close to our treatment targets, and we'll start taking confirmation samples of groundwater. And the probes will be selectively de-energized as individual areas meet the targets until all of them meet the targets and the whole thing will be turned off. We'll conduct a round of groundwater sampling as well as confirmation soil sampling to make sure that the remedial goals have been met. And that approach results in energy savings. So the sampling is kind of interesting because the groundwater is going to be so warm, there's a risk of losing VOCs to the air during standard sampling methods, which would bias the samples low. There's a stainless steel cooling coil that will be used before the water is exposed to the atmosphere in any way. This cooling coil gets immersed in an ice bath, and the water gets cooled to about 4 degrees C before the VOA vials get filled and sent off to the lab. There's a similar protocol for sampling hot soil, where the drillers will retrieve macrocores and they'll have a meat thermometer to stick in the end of it, keep it on ice, and wait until that temperature comes down to ambient before opening it up and collecting the lab sample. So we anticipate the system will run for about 6 to 8 months, and we're looking for an order of magnitude reduction in VOCs in both soil and groundwater, which is really exciting. And I think we're saving questions for the end. So I will go ahead and turn it over to Mona.
Good afternoon, everyone. Okay, can you see my screen?
Yeah.
Okay, perfect. I'm glad to be here and provide you with an overview of one of the interesting sites that is under Santa Ana Water Board's oversight within the footprint of the Orange County Water District South Basin Plume. So for folks who are new, I will just provide an overview of who we are. We represent the Santa Ana Regional Water Quality Control Board. Is one of the 9 regional boards across the state, Region 8 in Southern California, the pink area. And even though we represent the smallest regional board on the coverage area, however, our region is very industrialized and highly populated, and we rely heavily on our groundwater resources, as it was mentioned by Bill earlier. And protection of these groundwater resources is of high importance. So our jurisdiction is within parts of the Orange County, San Bernardino County, and Riverside County, basically the Santa Ana River watershed and its tributaries. So the map on the right shows the footprint of the Orange County Water District South Basin. Stars represent the sites that are under Santa Ana Water Board oversight. The specific site I will talk about is highlighted, and these sites are in various stages of investigation and remediation. To just provide you with an overview of historical operation at this particular site, the site was historically used to clean and recycle PTFE, polytetrafluoroethylene, and using acid treatment. So the reactor that was involved in this operation contained 70% perchloric acid with 30% nitric acid at elevated concentration, 300 degrees C. So you can imagine that how oxidizing this solution can be. So the pellets, those PTFE pellets, were after the cleaning and basically treatment using acid bath, they were neutralized and they were washed and placed in bins across the site for being drained and dried. So before we take a look at the effect of this operation, let's take a look at the area of the site. This site is not very large, it's 3.6 acres. You can see the on-site building. The processing area, that reactor area, was located in this area. And in old days, if you were at the site, you would notice the effect of that reactive wash water that has caused etching of the concrete at the site. The next photo also shows the impact of that. Before we get to the result and the result of investigation and the effect of this corrosive and very reactive water on subsurface, let me just provide you with a little overview of the hydrogeologic setting in the general vicinity of the site. So 2 water-bearing zones, these are the shallow water-bearing zones that were represented in the cross-section shown on Bill's presentation. So the first water-bearing zone is dominantly fine-grained formation, dominantly clay, to the depth of about 34 feet below ground surface, depending on the location. And second water-bearing zone is more coarser grain, sandy sediments, and the general groundwater flow direction is towards south-southwest. So now let's see the effect of those historical activities on the soil media. So you can see this is the ISO concentration contour map at the site in the soil media. The responsible party at this site, they conducted soil investigation every 3 feet, so very close, delineation, vertical and lateral delineation. Highest concentrations were detected, as you can guess, around the former PTFE processing area, concentrations exceeding 100,000 microgram per kilogram. Based on the properties of perchlorate, you can assume that what impact it could make on the groundwater, basically underneath this area. We will look at that later. And you can see that the extent of perchlorate in soil has also basically covers the areas underneath the building. And the reason here is that there is a secondary source from a leaky sewer pipe underneath the building as well. So you see also elevated concentrations in different areas of the site. How about impact to the groundwater? These maps represent the isoconcentration contour maps within the first water bearing zone and second water bearing zone on site currently. I should note that from the earlier years of this project, back in 2003, I believe, a pump and treat system was installed primarily for the purpose of containing the plume and preventing further migration of the plume off-site and further degradation of the water quality, down gradient of the site. So this is the current situation, is still the highest concentrations in the range of, exceeding 1,000 microgram per liter around the PTFE processing area. It's interesting to note that even though significant mass was discharged on site around the PTFE processing area, because of the type of formation, the second water bearing zone back in years and also currently is non-detect. And this is important when we discuss other aspects of the project. So how about the impact to the water bearing zones of site? To just orient you, this is the footprint of the site, and the map on the left represents the running portion of the plume of site within the first water bearing zone. As you can see here, the operation of the pump and treat system for almost 20 years now has resulted in detachment of the on-site and off-site groundwater plume. But a point that I would like to highlight is that you noted that the on-site area within the second water bearing zone was non-detect. However, when we stepped out of the site, the first water bearing zone plume has found its way, and basically it has dove in and migrated within the second water bearing zone that is even more transmissive. So that just highlights the importance of vertical delineation for, and that's why that we emphasize the importance of vertical delineation. So even though the on-site second water bearing zone was non-detect, the groundwater plume has found its way within the second water to move in the second water bearing zone and degrade water quality. Now, let's look at the actions that we have taken in time. So all the sites are under our oversight. They are putting together conceptual site model. This example site is one of the sites that has practiced one of the more comprehensive conceptual site models. As it was mentioned earlier, stages of the project included installation of interim remedy to contain the plume on site. And in addition to that, a combination of remedial technologies were implemented to address significant mass in soil and groundwater. And we will take a look at some of those actions. So remember that we talked about the PTFE processing area. So one of the actions was to excavate the concentrations in soil, the soil impact in soil, exceeding concentration of 100,000 microgram per liter within the VADOS zone to basically the maximum depth of 100,000 microgram per kilogram around the PTFE area, using large diameter augers with different diameters. The larger diameter, 5 feet, basically augers, were filled with mulch to also promote additional remediation using, biodegradation of perchlorate. What else? So earlier, I showed the impact of the operation of the pump and treat system on the plume, but the map on the left shows basically the first water bearing zone groundwater plume back in 2004. So you can see that how elevated concentrations were. So here in PTFE area, concentrations were exceeding millions of microgram per liter. And you can see that the smallest ISO concentration line represents still 100 microgram per liter. So the plume was extending off-site. And right now, the map on the right side shows the October 2023 ISO concentration contour maps impacted by decades of operation of this pump and treat. It's still highest elevation, highest magnitude of perchlorate are in around the PTFE area. Other areas show different pilot scale studies that have been done, and unfortunately, we don't have enough time to talk about those. How about the offsite plume? For the offsite plume, we started incorporating bioremediation. It started with a pilot scale study that was implemented back in 2016. Upon receiving promising result, the permeable reactive zone was extended to basically capture the entire width of the plume. So this permeable reactive zone is the largest remedial effort that is conducted in our region, including 232 injection points within 2 water-bearing zones. And as the groundwater passes through this barrier, basically the walls go to non-detect. So the groundwater gets remediated very effectively. To just emphasize the effort that has been done for bioremediation of perchlorate using permeable reactive zones off-site, this map shows again the alignment of the full-scale barrier. Additional barriers are planned more up gradient of this existing barrier. So this new barrier, basically what it does is that to intercept the plume in different areas. So that long plume is planned to be targeted in different areas so we can break it down and reduce the concentration. There's an important point here I wanted to highlight. As we continue to replenish this full-scale biobarrier, we are also mindful about evaluating the dynamics of the plume, taking groundwater samples, and ensuring that the width of the barrier is intercepting the full width of the groundwater plume. Another depiction of the full-scale biobarrier here. As a summary, this project is a great example of successful collaborative with this responsible party putting together a reasonably comprehensive conceptual site model and implementation of a combination of remedies to address the perchlorate impact within the footprint of the site and also in downgradient areas. With that, thank you for your attention, and I'll be glad to take any question.
Thank you so much, Mona. At this time, I'd like to invite all our speakers back on camera. We'll do a joint Q&A. Thank you so much again, Mona, Angela, and Bill, for your great presentations today. Let's see if we can get all of our speakers on. Mona, is it possible to stop sharing?
Sure.
Thank you. And we'll get Angela back on as well. Thank you. Now we could see you all here on full screen.
Okay, it says I can't start my video because the host has stopped it.
Oh, how's that?
There we go.
Oh, sorry about that, Angela. I didn't mean
No
to do
worries.
that. Well, thank
Quite
you
all right.
again. And I want to thank our speakers for jumping into the Q&A. I know we've gotten a couple questions very early on, and we've started to write some responses. So that's great. That'll keep this portion focused on some of the pending questions here. So I'd like to start it off with Bill. I think I'll pose this question to you because I believe it was asked during the cost breakdown that you were providing in your presentation. And Erica is asking, who is responsible for the costs?
Yeah, that's the responsible parties. The those responsible for releasing these contaminants into the groundwater are ultimately responsible. Unfortunately, those responsible may no longer exist anymore. So, it's not a direct answer, and Mona or Angela may be able to answer better on their side, and potential options for site owners to conduct remedies on the sites. But from the district's standpoint, and as discussed in my presentation, we identified responsible parties that that could contribute to our recovery of costs in implementing a remedy to clean up the groundwater in this area.
So from the water board's standpoint, these responsible parties are either the historical operators at the site or basically the current property owner. So per the California Water Code, we hold the current property owners responsible for the impact that exists at these sites.
Mhm. Likewise, the 4 sites that I manage in the area are RP funded sites, whether that's the current owner and operator of the business or a previous one. 2 of the other DTSC sites that are very close to the MB site are in our orphan portfolio. So there were not liable and viable parties identified, but the site was a priority enough to get state funding.
Great, thank you all for those comments. Question about angle drilling. How is the correct angle maintained over a large distance? And how do you control the drift of the drill stem?
Oh gosh, I wish I had a drilling expert on this call with me. I know that the contractor that the consultant has hired was involved in the design, and so I'm sure they have a smart way to handle that. I do not know what it is, but I can research that and get back to you.
Thank you, Angela. Thank you. And actually, I think this next question is for you as well, Angela, because it's related to the MB site that you spoke about. Is the proposed thermal treatment at MB being used in conjunction with the microbial biotreatment? And there's kind of a follow-up question about, is it known whether the thermal treatment would impact or change the microbial community? And will that enhance microbial remediation or limit it?
That's a great question. Thank you for that. So in the short term, the microbes are not going to enjoy the heat that will exist in the core of the plume. The temperature will approach the boiling point of water, and so the microbes will not survive in the center of the plume. On the edges, in the areas where the temperatures are elevated but not lethal, that should stimulate microbial activity. And then after the electrodes are turned off and the site starts to cool, that'll take some time because of the energy retention properties of the soil and water. So for a long time, the entire site will have that non-lethal but elevated temperature, which will stimulate the microbes to recolonize and then work probably more efficiently than they ever did. So we're probably going to get kind of a free boost to the width of treatment, as well as ongoing positive effects in the future from the heat and how it will affect the microbes.
Thank you, Angela. And if I may throw one more your way regarding the MB site as well. Can you talk a little bit about the kind of why the remedy was changed from injections to electrical on the MB site, and talk a little bit about, were there surrounding sites near MB being remedied?
Yes. The site is in a really densely populated area of commercial businesses, and lots of those are active cleanup and assessment sites with either the water board or DTSC or the local CUPA, which is Orange County Healthcare Agency. So there are other remedies going on at those other sites, like Delayed Chemical has got a dual phase extraction system. Former Dyson Electronics has done a soil removal, and they have some in situ work that has been approved, and it's working on scheduling implementation of it. Cherry Aerospace is doing soil vapor extraction, and they have a pump and treat component that's been approved, and they're in the permitting process. So there is a lot going on in the vicinity, and through keeping the neighboring sites kind of in the same shop, as well as coordinating with my counterparts at the other agencies, we're able to kind of have a big picture view of making sure that we don't have sites next door to one another where this one's doing oxidation and that one's doing reduction, and in the middle you have a mess, right? We want to avoid that. And as far as changing the remedy, so the injection that we've done so far has had some positive results, but it's kind of tough to get the material everywhere that we need it because it's very heterogeneous with finer deposits that interfere with getting really great distribution. And so we're still thinking that that's going to be a component going forward, but we haven't been able to get the volumes and the distribution to use that remedy alone.
Thank you so much, Angela. I appreciate those responses. Sure. Bill, I think this question is for you, but for others, please jump in. How many wells are used in pump and treat? And what is the total groundwater discharge rate, and how is that water disposed?
If we're talking about Orange County Water District's Alternative 3, I believe in the feasibility study, we had estimated a total of 75 extraction wells, extracting on the order of 350 gallons per minute combined. These are relatively fine-grained, very thin aquifer units. So I think our extraction rates were very low on a per well basis.
Thank you, Bill. Jumping.
All of that information, it's obviously preliminary, and our next phase of the project will be a preliminary design investigation where we'll actually go in and install test extraction wells and pump them to get more accurate estimates of our extraction rates and potential capture zones and potential number of wells needed to have an effective remedy.
Thank you, Bill. I just want to do a quick time check. I know we're at the top of the hour here. Our speakers have so kindly are willing to stay on for a couple minutes longer just to, so I think if we can get through a couple more questions, and again, if we're not able to get to your question during the time allotted for the live portion of the webinar today, we'll circle back with you afterward. So thank you all for sticking around for just a couple more minutes. What stormwater requirements and limitations do you require for sites within the southern portion of the OC Groundwater Basin?
For us, we don't have any. Orange County Water District doesn't have any stormwater requirements. That doesn't fall within our jurisdiction. I believe that's a regional board, actually.
That's correct. So the industrial sites are subject to the stormwater requirements per the requirements of our stormwater program. I can connect whoever has this question with our stormwater section so they can answer this specific question.
Thank you. And we do have another question about sort of, I think, similar to that. So Mona, if we can shoot those questions over to you as a follow-up.
Absolutely.
That would be great. Thank you.
Sure.
Thank you. I just want to end on one question here where we're a little past the hour. Someone asked a really great question about, will there be another community meeting for community members? And I know that this group has had a lot of community outreach and meetings about this particular project. If you all can touch a little bit about your community outreach efforts in the past and maybe looking ahead, that would be great information for our attendees today.
I can start. We have conducted several community meetings, primarily focused in the Delhi community because that is the area in closest proximity to these contaminant sites. That is in the eastern portion of Santa Ana near Warner Avenue. But we've also held public meetings related to our notice of preparation of our CEQA document for this proposed plan and we will hold another community meeting when we issue the proposed plan and the draft EIR for the 45-day public review period. That will likely occur in the fall. If there are any other specific needs, feel free to reach out to our public affairs department, and they can arrange to have OCWD come and talk about what we're doing in your area.
Mm-hmm. I can add a bit to that. In the cleanup process, there are a few touch points where the statutes that we implement require us to do outreach. So I did a meeting like that last week at the Delhi Center, where we had our public comment meeting for this work plan that I just shared with you. And then over and above that, we've been invited to participate in meetings that were hosted by the City of Santa Ana, the Delhi Neighborhood Association, Madison Park Neighborhood Association, and those kind of are done kind of as those things come up and we get invited, we come out to answer questions and share updates. We don't have the regularly scheduled outreach, and but there's no reason we couldn't collaborate on a schedule that would be frequent enough to satisfy the questions that the community has.
Mona, would you like to add anything about that?
In general, since our sites within the South Basin are located in the dominantly commercial industrial area, we have not conducted any community meetings, but we have issued community fact sheets to just notify about the existence of these sites, particularly when there is VOC impact, and informing the community that basically the surrounding area that there is impact with these chemicals and environmental investigation is going on.
Mm-hmm.
That's great. You know, and with that said, I just want to pull up one last slide here so folks can see that, you know, just if there's any follow-up questions after the fact. And I just want to thank our speakers once again. Thank you for sticking on a little bit longer past the hour. Really appreciate it. And thank you to all our attendees who also stuck around past the hour as well for joining us today. A friendly reminder that this webinar was recorded and it will be posted to the OCWD YouTube page, and our slides will be made available as well. And if you have any questions, if we didn't get to your question live today, you know, please reach out to us or vice versa. We will be following up with you. And if you think of anything after the fact and want to get in touch with us, you could email us at info@ocwd.com. As Bill mentioned, that is the email address to the Public Affairs Department. So please do reach out to us, and thank you again, everyone. Appreciate it.
Thank you all.
Have a good day. Bye, everyone.
Bye-bye.